Hi there, this is Dr. Unbuddy, and talk to you about Project 3. Now, the basic idea of Project 3 is to read a file, get some data out of it, and do some simple analysis of that data. And we're in the process, we're going to play a little bit with strings, we're going to work with functions, and to help this process out, we of course give you a data file, and one of the ideas that I have for this course is that I want to give you the power to use data files and do some analysis on it. So that's this first step in doing this. Now I picked some economic data, and the reality is that whether you're a scientist or a political scientist or an engineer or whatever, a lot of times you're going to use data files. And this one I cleaned up a little bit so that we can use slicing. We'll find in the next project that we'll have some better tools so that we'll actually be able to handle Excel files. But this is a step in that direction. And in fact, I'm a great believer in that you shouldn't believe anything you should hear. You should go out and find the real data and take a look at it and draw your own conclusions. So here we picked some GDP data. I grabbed a file from the government. The only thing I did to this file is I shortened it a little bit, and I also made it so that it was a little easier for us to read just using string slicing. So all the tabs and things like that were replaced with spaces and so on. Otherwise, it's basically a raw data file. Now the requirements of the data file here are that we're only interested in lines 9 and 44. And so I can give you any kind of a file that has the same number of rows so that we can always look at lines 9 and 44, but I may modify the number of columns so that we're actually looking at data from different years. So let's take a look at some of the things that we have. If I put that data, if I were to open it in a spreadsheet such as Excel, so this is a table of GDP data, and I arbitrarily said let's be interested in the information in line 9. Now, not the line that's numbered line 9, but the line that is line 9 of the file. And the idea is, this is a big file because it starts in the year 1969 and it goes all the way up to I forget, maybe 2015, something like that. But there's a lot of rows. There are a lot of columns in this data, and the idea of this project is that we're going to go through and we're going to look at each data item and we're going to try and find the smallest one. And here, at least what I see here, looks like maybe this is the smallest one. Now it turns out that as you go through this, the whole data, it will look a little differently, but up to this point, that's the smallest one. And what I want to do now is I want to find the corresponding value down here. All right, so I want to find the minimum value here and then find out what the gross domestic product is there. And then we'll at the same time, after I've done that, I'll go through and I will then find the maximum value, which maybe in this set of values is maybe this one. And so then I'll want to have the GDP associated there. So that's what our task is. We're going to look at line 9, go through and find the minimum value, this case there, and then go down to line 44 and then find the corresponding value. So in that column, what's the corresponding value there? And then when we find the max, what's the corresponding GDP value there? And we're going to have functions that do that. So we'll have a function where we pass function line 9, and it will find the minimum, and then there's another function we pass that same line, we'll find the max, and then using those the indices. So in this case, if I count it over to here, what is the index? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, so we're at index 15. I'll use that index down here to get the corresponding value out of line 44. So that's the overview of what we're doing here. And as I said before, I will give you any file where the information is that we're finding for the deltas is in line 9. That will be fixed. Same thing on line 44. So we'll take advantage of that. What might be different is I might vary the years that you have here so that there's a different min and max in there. I'm allowed to do that in my test cases. I might create a new test case that does that. All right, so there's that's the general picture. And when you go to look at the file, there it is, gdb.txt. It's a text file. And then on Mirror, I give you a if you look on there, there's a starter code for you to download. And that's to make your life easier. In particular, it makes it possible to do the testing that I give you. So you download that starter code. And this is what that code looks like. And it's got a couple of characteristics that are important. One is it does have a main function. And every one of these functions you'll see has the word pass. That's because this is now a correct Python program, and a function needs to have a line, and the pass line basically says, okay, here's a dummy line that doesn't do anything. And so you have to replace each of those pass lines. But this code will run in its current, it doesn't do anything, but it will run. And then you've got this funky looking call to main. And the reason we do this is that this lets us build the unit tests so we can have tests so you can test individual functions one at a time. Now it turns out that the open file function, we can't really test that. The display function, we can't really test that separately. Those will be tested when we test the whole program. But these other functions, I can build unit tests for those, and we can test them individually. And the structure to this is that we're going to open the file. So in my main, first thing I'm going to do in here is I'm going to open my file and extract a line out of the file, and that line will be passed to find the minimum percentage, and that gives me both the value. What's hidden here is the index. Both of those things will be returned. I can then use that index. So this really is line 9 that's being passed there. That's really line 9 that's being passed there. And the line here is actually line 44. And the index that I get out of each of these functions is the index that I'm going to use here. And then when it's all done, I display it, and I give you formatting to a format string to help that out, so it'll be easier to do our testing inside of Mirror. So the first thing to do is to open the file. There are two stages to this, and one strong suggestion that I have is when you build a program is you leave testing for errors till the end. Just get it to work. And so what's the basic thing that I need here? And I need a file name, which I need to input, and you'll have to check and see, what you got to make the prompt look right. It isn't this, but and now I take that file name and I open the file using that file name, and I'm going to open it for reading. It turns out I can actually leave that blank because by default it reads, and then I return that. Now this is just a quick and dirty way for me to get started reading the file, because it's handy sometimes to write yourself a note that need to add exceptions, need to add try except later. right? And so you'll have to complete that. Now I can take this function, which takes no arguments, and down in here I need to replace that line. Oops. And what do I'm going to return a file pointer, and I will call the open file. Now the question is, did this in fact work? And so the first thing I always do is just check to see if things are working, and just print the line. Just go through the program and print it, and in this way I can see, like for example, do I have it set up where I can actually read this file? And the important thing is that the file must be in the same directory or folder as your program, and if it's not, this won't work. And so this goes and prints out the whole file. There's a lot of stuff in there. It's all the things that I showed you in the Excel spreadsheet, but now I know I have correctly opened it. All right? And then I can start from there. Well, I need particular lines, so let's have a counter in there. We've done this kind of thing before, and count plus equals 1. If count, we need lines 9. If count equals line, print. I'm just testing here. Line 9 should be the line that I'm at. And if count equals 44, print. That should be line 44. That's the current line. Now it will print out 2 lines, and I can now see, I got to put in my gdp.text, right? And it prints out lines 9 and let's see. So line 9, 1 gross domestic product, some weird things there, 3.1, 0.2, and so on. And now I can go and check. And there's a 1 and the gross domestic product, and that whatever field that is, and then 3.1 and 0.2 and 3.3 and so on. That looks right. My line 44, gross domestic product, some key value there, 1019, 1075, and there we go. We can see that my values. There is the 1019, 1075, and so on. So now I have proved to myself that I've got this thing working. And what I need to do is, now that I know that I'm at this line, this is where I will call my function, and let's start with the minimum function. And again, as a test of this, I'm just going to print the line. I'm in the min function, just that'll let me know, and I'm going to just print the line that goes in there. And so instead of printing the line here, I'm going to call that function. Now that function doesn't do anything. If I want to do this, copy and paste is kind of handy there. And let's see whether this works. Okay. And did it print line that, now we can see that I printed this just to see that, yep, I'm inside the function. There it is. And did it print the right line? Yes, there's the 3.1, the 0.2, and the 3.3. Now I know that that inside of this function, I am dealing with line 9. Okay. I'll want to check this in the find max, and down here on this one, I'll want to make sure that I'm dealing with line 44. Then in here, what I really need to do is calculate a minimum. I describe in the how we do that. And the basic idea is start with something big, and then you know, like start with 1 million. And then you look at each value and say, all right, is 3.1 less than 1 million? Oh, it is. Let me save the 3.1. You go, oh, 0.2 less than my 3.1. It is. Okay, so now I have a new minimum value. Is 3.3 less than my 0.2? No. And you keep going along, go through all these values until you've found not only the smallest value, but you also have to keep track of the index at the same time. And so when we're done with this, I am going to have here return my minimum value and the index of my minimum value, however you calculate those. And you'll do your other function here, the max. It's just like the min, except that in finding the minimum, we're going to find the maximum. So you can use copy and paste. Once you get this correct, you can then work with that function. Now, once you get both of those functions correct, then you have to find the corresponding index, corresponding GDP value out of line, the line 44. Use the index that gets returned, and that will be returned here. I will say something like min value and index of min value. The names don't have to be the same. I could call them Fred and George if I wanted to, but what happens is that these two values here that you return, that's what's being returned from here in order, so that min value goes into here and this index value goes into there. And then you can use that index value is what you then send in as an argument to the find GDP. So hopefully this gives you an idea of how to go about solving this problem. There's a number of things that you have to do. We've done a lot of framework building here to get this a little further. There are the individual tests will test the functions by themselves. So you will test the find min percent and the find max percent and so on. And once you get everything working, once you get this project working, then you want to remember to go back and, I've got to get the try except stuff in there. And how do you do that try except? There's a lot of good stuff in the book for how to do that. All right, good luck.